Oh, yeah.
Okay, good morning, folks. We're gonna have a few more lectures and then break over to final projects full time. But I'll probably talk for another couple of weeks. So, as we sort of merge into final projects, I'm willing to take requests for what you'd like to hear about. I have one request already, and that's for more sensors and more motors talk. I2C, okay, I can do something on that. Send me email if you have any other ideas. I am going to spend a little bit of time talking about, and I'm going to have you read some stuff on some journal articles on safety. Particularly embedded control safety. Embedded controls are everywhere. They're all through your car. What would happen if your cruise control stuck full on?
You have a Toyota.
You have a Toyota. Wise guy. All right. And I actually had a student once who wanted to build a cruise control as a final project and put it in his car. How are you going to test this? And what is your insurance company going to say? Oh, I hadn't thought of that. Yeah. So safety is an issue, particularly with embedded systems. We need to talk about safety. And maybe a little bit about standards, but quite a lot about safety. So it'll be 2 or 3 lectures on safety. And I'm going to want you to participate. In other words, I don't want to stand up here and talk about safety. I want you to have an opinion. I want you to read the articles that I'm going to assign, and I want you to have an opinion. Because it'll come down to one of 2 things. You will either have an opinion or you will have a test. That's the way it is. Because this is an ABET CDE course, and I have to be able to validate that you participated in safety learning. The only way I can do that is either you talk or you take a test. Okay? So you're going to read the articles. You're going to form opinions. That means that this is not just-in-time reading where you sit there with your laptop open and scan as fast as you can while I'm talking. All right. But mostly what I want to do today is to take questions for Lab 4 and also then talk more about final projects. One question that came up is that if you're plotting the control parameter, the motor control parameter, the output to OCR0A has to be between 0 and 255. And you may be generating some large positive numbers or some large negative numbers on your output control parameter. And so prudence suggests that you clip it to 0 if the output is below 0. And you clip it to 255 if the output is above 255. If you don't do that, and you merely assign a float to OCR0A, it's going to wrap, and you will have periodic speed control rather than monotonic speed control. That's a bad thing. Any other questions about PID algorithms, tiny real-time? Optimal control? You could do it. I've seen it. I can't do it, but I've seen it. I've seen students do it. I mean, I can't. I just don't know the algorithms.
Do we need to have some kind of a method for choosing our gains, or can we just sort of guess and check?
What I'm going to suggest here is that you do it iteratively. I guess that's called the guess and check method. I would call it downhill pursuit, where you search along the gradient in a high dimensional space until you find a solution. So you're going to change a gain a little bit and then change a differential gain a little bit, see if it gets better or worse. And you find a direction in which it gets better and you go that direction. It's kind of it's called a simplex search method.
And we probably do that with MATLAB.
You do it with MATLAB. Yeah, you can do it with MATLAB to the degree to which the model I wrote is good. You can do it with MATLAB. To the degree to which the model is the MATLAB model is an approximation, that won't work. But you can certainly use it as a starting point. Any other questions about Lab 4? We'll be open tomorrow morning. We'll be open Wednesday morning. Hopefully that'll make up for the pressing reset in the middle of your forehead. The same thing happened to me over break too. Came in this morning and went, oh, where are the parts? Final projects. Let's talk about is there no more questions on Lab 4? Let's talk about final projects. Yeah.
One more question about Lab 4. So when we did our design, when we first power up the system or reset the system, sometimes the model will just stay still, and until we manually let it have some kind of rotation, and then it will start to.
So the problem here is that you can't get a speed reading unless the motor is running, and the motor's not running until you get a speed reading.
So is that okay?
No. How could you easily fix that?
Have some initial speed?
Yeah.
Okay.
Turn on OCR 08 at full speed for 0.5 seconds.
Okay.
You know. Is that a question or are you scratching? Okay. Anything else? So I thought I'd go through some of the Lab 5 stuff, design project, just so that you've heard it and have a chance to ask questions. Remember that during most of this time, you got no other assignment. There's going to be no homework, there's going to be no lectures, there's going to be no nothing, which means the entire course load is lab work. That means you need to be in lab work 12 hours a week. Minimum. There's going to be about 20% of your project grade, which depends upon routine workmanship. If you do a great project in the last week, you'll lose 20%. All right. So you need to work steadily. It never happens, but you know. So you need to work steadily. About 30% depends on the project demonstration at the last day of class. So the last week of class, I think the last day of class is Friday, May 3, May 4. Slope day.
Not if there's a performer.
I don't know if there is or not. I pay no attention. So we'll be done by then. 50% will be based on your project write-up, which is due the very day that you demonstrate. And I have to say that if we see a gross disparity between the work that two partners are putting out, we reserve the right to grade partners differentially.
Write-up as paper or write-up as website?
Write-up is website. Has to be in HTML. Write-up is in HTML. Please don't use Microsoft products to generate the HTML. It always breaks on our server and I can't fix it. Download a free demo copy of Dreamweaver. It's better, the price is right, and it does a bunch of other nice stuff for you. And there will be a bonus for finishing early. I love it. Here it is. the bonus is we're going to round 2.7 times the floor of the number of days to the 0.5 power. Yeah.
Yeah, it won't compile.
Won't compile. Not even MATLAB will take that. How did I come up with that? Because I wanted something that gave a fairly large boost at short times, but not a huge boost at long times. So this saturates to about 15 points at 30 days, but gives about a 5 or 6 point boost at 7 days. The idea here is to decrease lab congestion during the last week, because it gets insane.
The lab writeups that are doing the day that you demo, does that include if you're demoing early?
It does include if you're demoing early. If you demo early, you finish the documentation early. Demo means you're done. You're done, but that means you have to do the documentation. And you demo to me. I mean, if the TA is there, that's great, but I have to see every demo.
For the 12 hours a week lab work, you don't actually require us to be in the physical lab, do you?
No. You do need to appear, though, during your lab period. The TA has to be made, it has to see your smiling face during your assigned period. And let me remind you that while you have to write an HTML page, and we have to see it, and you have to print us a copy of it, then you do not have to submit it to the website to be included on the website. It is your intellectual property. You can choose to not submit it. About 80% of people do submit their final project, and people who don't do so for a number of reasons, including patent protection. If you think there's a patent opportunity on your project and you submit it and it's on the web, that counts as a publication, which means that in the United States you have only 1 year to attain a patent on it. And outside the United States you have 0 years. So if you think you're going to want a patent, then you don't put your project on the website. You have 1 year to apply for a provisional patent. No, nobody gets a patent in a year anymore. It takes about 3. Thank you. Now, I find it very useful if 4 years from now you're going to email me and say, could I get a recommendation for grad school? It's really nice if I can go back and look at the project and say, oh yeah, I get an image of the person and the project and so on. So if you think you're going to want a reference from me 4 years from now, when all I can remember you by is your smiling picture on the cheat sheet I get and a 1-line grade average, put your project on the website. I brought up a channel for the 4760 projects on YouTube. I would like to accumulate project videos on the channel. I'll be in the lab with a 1080p video camera during final project demos, and with your permission I will put up the video of you or your project. And there will be probably, very likely, there has been for the last 3 years, a contest, hardware contest, software contest, in which 4760 projects compete with MEng projects for prizes on ECE Day. And the 4760 projects are very competitive. So if you want to do that, I would encourage you to think ahead about packaging for a project for a show kind of environment, for a poster session where you don't have lab support and you will not be allowed to use an SDK 500. You must build hardware if you're going to do that. Any questions about that stuff? We only have about 30 STK 500s. That means that at all times, all groups will be limited to one SDK 500 for any purpose. If you want more processors, build them. We got plenty of prototype boards. In fact, I just ordered up a new batch, so we have about 40 or 50 left of last year's. The new batch for this year is really the same, except that the communication interface has been cut off and put on a separate board. So the board is 9 millimeters shorter than last year's. And I'll show you those when I get them in. They're not quite here yet. And again, of course, no projectile devices or weapons of any kind. Goes without saying. And no drug or alcohol related projects, except perhaps a breathalyzer. If you can figure out, if you can convince me that you can test it without doing anything, without drinking in lab. Because we can't have that, right? No, no. Thank you. No. You have to come to lab ready to work, which does not include, yeah. You have the so you have your friend come to lab. So what I've said in the past is I've had 2 people build breathalyzers of various complexities. You have to figure out a way of using an artificial alcohol source to test it. What people used was to put a measured amount of alcohol into a turkey baster, shake it up, and then hoof it into the sensor. I'll buy that. And one group said, well, we also calibrated this in the dorm. And I'm okay with that as long as you're 21. You know, that's not my business what you do outside of the lab. The budget includes MCUs, boards you build, power supplies, parts you order, and everything else you buy. So if you build a proto board, it's going to cost you $4 for the board, which is about my cost, by the way. $4 for the board. About $6 for the CPU, and then a little bit more depending on what kind of connectors you put on it. Amazingly, connectors are often more expensive than the integrated circuits. So the those nice wires that you use are going to be $1 each, and header pins are going to be 5 cents each, 5 cents a pin. Think about whether you need this. And the reason for this is I find that if I don't budget those, people use a lot of them, like hundreds. We'll connectorize everything. And it's very flexible but very expensive. You do not have to budget hardware you owned at the beginning of the school year. Anything you own before that, you don't have to budget. So if you have an old RC car laying around the house, your parents would love to get rid of, you don't have to budget that. You don't have to budget samples from Maxim-IC or Freescale or so on. You don't have to budget hardware you scrounge off the loading dock. And of course, any projects that involve groups, research groups outside the course will negotiate for budget, but basically will waive the budget if the principal investigator agrees. So you can read the budget details online. There's a whole list of stuff. In terms of the write-up, don't leave it. The appropriate way to develop here, since you only have 5 weeks, is to develop the documentation at the same time you're developing the application. It's really tempting to get the thing running and then write the whole thing the night before. But the lab report is worth more than the demo. The written lab report is worth 50%, the demo is worth 30%. Put some time into the write-up. It matters. It matters for your grade. It matters for the next student who tries to use your project as a basis for code. By the way, you're welcome to use any code you find online or any place else as long as you acknowledge that you used it. And as you sign, by being in this course, you have said that it's all right for us to use Turnitin to look for duplicate code. So use other people's code, but tell us that you did it. It is not easier to use somebody else's code. It's a different kind of work than making it up yourself, but it's not easier. Anybody had experience with this one way or the other? Recycling code?
Yeah.
Yeah, fun, huh? What were you, was that Verilog?
Yeah.
Oh, that's extra good. You would be surprised how many people don't put their names on their reports. And then I have to search through the metadata to find net IDs or something to identify it. That's why there is a rather lengthy outline. It's one whole printed page outline of what should be in the final report. The very first thing it says is student names. Boldface. Blinky. Optionally put on net IDs. Don't feel like you have to put a net ID in the report unless you want to get email about the report. And let me tell you, you will. Some really strange stuff. And it goes on for years. And some of it, I mean, if you're entertained by that and you want to do that, that's fine. If you feel like you want to help people learn stuff, that's fine. But don't feel like you have to. I'm happy to be the buffer for that.
We wanted to hold off on putting a report up online for a year or two so we get it published. Can you do that?
That's fine. I'll take a report anytime you give it to me. If you want to hold off for an academic publication and then put it up, that's fine. We want the idea of the report should be enough detail that you could reasonably be expected a year from now to build it from the report. So your audience is you 1 year from now. That is to say, a rather sophisticated, knowledgeable audience, yourself, and but long enough in the future that you don't really remember the details at all. Right, so it should be complete enough that somebody can take it and, with a knowledge base like this class, be able to reproduce it. That's what we want. There also needs to be, again, this is an ABET course. This is there's a certain structural requirement in the course for content. One is societal aspects of your project. Did you use standard video? Oh, well, what's the standard name? Are you using 802.11.4 communication? Are you using Are you attempting to transmit data on 434 megahertz? Turns out, for several years, I was having students do that until one student 2 years ago told me that I was asking you to do illegal things. And it turns out that on a closer reading of FCC Part 15, very important, FCC Part 15, low power devices, it transpires that routine data communication at 434 megahertz is only allowed if the field strength is below 200 microvolts per meter at 3 meters from the transmitter. That's nothing, folks. That's about 5 microwatts output, 10 microwatts output. The little $4 transmitters I was buying for the course put out a milliwatt. Oh, were we illegal? Now, would anybody ever notice? Don't know for sure. I don't know what the range is, but the fact is that it was illegal. So you're going to have to show me, you're going to have to prove to me, if you use radio devices, that you are legal. You can do this in various ways, but you need to talk about it. It would be a required part of the write-up. There are a few projects for which, well, I want some statement of safety, but there are some projects for which safety has to be discussed. You're firing an infrared laser across the lab. I'd like to hear some words about safety. You're doing a captive archery thing where you're pulling back a bow and arrow and then the arrow stops, dork, right here. I'd like to have some words about safety. Or, for that matter, video games that flicker or flash a lot, as you know, can cause seizures in some people. So there are lots of ways in which we'd like you to talk about the safety and usability of your design. Another thing you might consider is if you're using color to code some output, let's say a green LED or a red LED, where you have to discriminate two colors, or color television signal. 6% of males are colorblind or red-green colorblind. Maybe you better design it so there's a geometric hint, like red on top, green on the bottom, like stoplights, so that you can get the color from the geometry as well as from the wavelength. So a little bit about human factors would be useful if you think that if that's appropriate. Intellectual property considerations. Did you reuse code? Did you use code in the public domain? What does a GNU license actually say? Anybody know? Who'd like to quote it? I'm sure somebody here knows it. No? Look it up. You have to be very careful how you reuse GNU licensed code. Are you reverse engineering a design? Let's say you're doing Angry Birds micro version. Uh-oh. That's probably got copyrights all over it as well as trademarks. How are you dealing with that? Are we going to call this angry faculty? And you throw mortar boards at things, or you know, how are you gonna deal with trademark issues if you're reverse engineering something? And I suspect that this won't happen, but it could. I've seen it happen in the past. Some companies will make you sign non-disclosure to get a sample part. You can't do that for this course. Unless you're doing it for a research group. You cannot do that. Because as soon as you put that in your report, and I haven't signed the non-disclosure, you're violating it. And of course, the positive side, are there patent opportunities for your project or the publishing opportunities? And I want to talk a little bit about ethics. One of the more interesting things that's happened in the last few years is in which it was a plagiarism case in which, I think I may have told you this part of this already. The students were the good guys. The student project was plagiarized by a researcher and put in an IEEE journal. And so you need to think about how you are going to protect your intellectual property once it's on the web, where it's easy to steal. What is your strategy for making sure that nobody copies a published work? You may have a strategy. Think about it carefully. You're going to need one. And I'm going to want you to talk a little bit about how your project fits into the IEEE Code of Ethics. So there's a little bit of this is sort of almost becoming a little arts and sciences like on one end of it, and you're going to have to deal with that. And I don't want a bullet list. We were honest. Yeah. We didn't copy anything, for sure. Right. Nobody I mean, obviously you're not going to say you lie, cheat, and steal. So it's the borderline cases that are interesting. It's the cases where you can't quite figure out what to do, and that's what you need to talk about. Now, in terms of, I'm going to say this, and you're going to forget it, but hopefully you'll remember that I said something about it. And that is, we're going to save these things on a Unix server. We're going to put all these projects on a Unix server, not a Windows server. Spaces in file names don't work very well on Unix servers. There are certain characters which you're allowed to use in Windows that you better damn well not use in Linux. And in particular, Windows doesn't care about the case of file names. So in Windows, JPG is equal to JPG, but that's not true. But that's not true in Unix. All right? That's not true in Unix. Don't do that. And I say, well, it turns out half the group will. And the reason that they will is that Windows has a tendency to change the case on files when you copy them. And so you'll put everything together, it'll work, it'll be all correct, you'll copy them to a new directory, and it'll still work on your Windows machine, and as soon as you send them to me, they won't work. And then I either have to fix them, which I sometimes do if it's simple, but if it's a real mess, I have to send it back to you, and then you get annoyed. So check the case of file names, keep the file names simple. Don't put exclamation points in your file names. Unix really doesn't like that. Yes?
If we want to post it on our own server as well, can you just link to ours, or do you want also a page specifically to be hosted on our server?
I would prefer to have the page because experience shows that students don't maintain files for as long as I do. And so you're welcome to make a copy. Keep your own local copy. I'm happy to link up a local copy and your copy, link them both up and say best copy, local copy. But I'd like a local copy. If you care to do it, it's your decision. So, I blasted a lot of information at you. What are your questions? So do you need to obtain permission for code reuse? It depends on the license. For GNU license, no. But you do have to include the complete original license at the top of every file and make all of your work public. So if you use GNU license material, you've made it public. You will make it public. If you use material off of our website, you need to link the project page.
And mention the name of the.
And preferably mention the names of the students, yes. If you can find it on the web page. What else? Five weeks is a long time. It's really easy to coast for that first week and a half. Don't do it. First, parts will be ordered. First round of ordering will be next Monday at 0800. I'll start ordering then, and it'll take me about an hour, hour and a half to get all the parts entered probably. And then the next time I'll order will be a week from then. No questions? Yes?
So, can you email me about the parts at 0800 on next Monday?
Yeah, they have to. If it's not in my inbox at 0800, it won't get ordered until a week later. And what I need from you is a mail file that has, in plain text, not as a spreadsheet, not as formatted text, not as an image, but as cut and pastable text in the body of the file, the quantity, the name of the part, the exact part number, and for DigiKey it always ends in -ND, and then the vendor. So if I can't figure out what something is, I don't order it. If the part number is wrong, if it's missing a dash, if it's uppercase instead of lowercase, and the search engine doesn't find it, I don't order it. It's got to work the first time. Because I'm doing a lot of these. There's around 100 of them or 150. And I'm doing a lot of them, and it's just got to work. So copy yourself the email, take the part number in your email and paste it back into the DigiKey search engine, make sure it comes up with the part you want. Also, if you're buying integrated circuits, really be careful. So the cheapest packages are not necessarily human solderable. If it's an MD70 package, if I remember right, it has no leads at all. You have to be able to solder on the bottom of the thing. Uh-oh. I mean, a wave solder oven could do that, but a human can't. So if you have any doubt about packages, ask me. I have a pretty good idea. SOT23 is easy. It's small, 3 millimeters by 3 millimeters, but it's easy. SOIC is easy. SOIC, small outline integrated circuit. TSSOP, not so easy but doable. Thin quad flat pack, ugh, awful. Leadless carriers, don't even think about it. So look carefully at the packages. I'll be happy to hazard a guess by email whether or not you can, or in class, whether or not I think you can solder it, or I can solder it. And I will also I think I said on the website, I'll take orders for DigiKey, and I'll also take orders for all electronics. Allelectronics.com. They have pretty good surplus motors and liquid crystal displays and various other items. The DigiKey is a little bit harder to find stuff in, and it's sometimes cheaper. Outside of that, you'll have to buy it yourself. I asked DigiKey to do 3-day air. So I order on Monday, they're usually here on Thursday. That's kind of the sweet point. If you don't specify, it goes by ground and it takes 10 days. And shorter than 3 days is just prohibitively expensive. So 3-day. You know, I wouldn't bother buying anything that's already in the lab. So resistors, thank you. Resistors, capacitors, op amps. These are slow op amps, folks. LM386s, LM358s. LM358s don't bother with. TTL logic we have in the lab. We have a lot of TTL logic. A cabinet full. Don't bother to buy that if we have it. Analog muxes, we have a few DAC converters.
What range of crystals do you have?
I have 8, 16, and 20, and then a scattering of weird ones. 3.586 megahertz. Anybody guess what that's for? That's the color television subcarrier frequency. That so 20th century. Sure, infrared LEDs, we got a pile of those. Yeah, so we'll budget those as something reasonable, 10 cents each or something. Yeah, don't go off. How many do you need?
Probably around 30.
For that, if you need 30 or 40, yeah, you're going to have to buy them. If you need 1 or 2, just take them from the lab. But if you're going to clean me out, then you have to buy your own. I had one guy say, "Yeah, can we use red LEDs?" Sure. How many you need? 250. Well, they're building a 3D cube, a 3D display cube, right? And they needed a pile of these things. I made them buy those. They found a source 4 cents each. They were cheaper than I'd found. Yeah. I can't remember. I think it was one of the surplus places. But you'll have to look around. It might have been American Surplus.
It might be noted on the project.
Good point. Good point. Might well be noted on the project. Go look for the 3D display. Parker Evans. Yeah.
Do we have any limitations on the number of CPUs you get from the lab?
Only until you run out of budget. At $6 a pop for Mega 644s, $1 each for Mega 32s. You could buy a lot of them. Remember, you need a crystal for each one. Or you have to build a clock generator. Let's say you want all your CPUs to be exactly in sync. Let's say you're going to do a shared memory supercomputer. And they all need to be cycle accurate. You need to run them all from the same clock, and so you better build a heavy duty clock generator and drive all the chips from the same clock. So you had a person, MN student, do a 4-way symmetric multiprocessor using Mega 32s with one Mega 32, a fifth Mega 32 as a switch. So one Mega 32 acted as the active switch, as a crossbar switch, and the other 4 ran a small kernel to do shared computing. And he got decent speed up for some simple stuff. He did it all in 2 weeks. He did his full MN project in 2 weeks. Sitting in the lounge. He didn't leave for 2 weeks. Oh man, what a beating. Sleeping on his laptop. It was nice and warm, you know. Oh, don't do that. Anything else? We will keep the lab open as much as we physically can during the 5 weeks of final projects. That inevitably means that there will be less help at any given time because we have to spread the staff out over more hours. We do not intend to keep the lab open all night. It is a bad idea for you, and it's a bad idea for the TAs. You may think you're productive all night, but you're not. And I'm not going to do anything that encourages you to work till 4 a.m. because it's wasted time and it's bad for you. Yeah, I know. I'm not your mother. So anything else? Okay, I'm going to talk a little bit next time about, I thought I'd talk, do you want to hear more about tiny real time, or is this old news now? Old news? Do you want to hear about more about how RS-232 works, serial communication? Yeah? Oh, that might be fun. And I can talk more about sensors. Any particular kind of sensors you want to hear about? Accelerometers? Accelerometers? Accelerometers are cool. There's one project I thought would be really nice, self-contained, would be making a level, making a carpenter's level using accelerometers. You should be able to get within a milliradian. Papers coming back from Joe and from Friday. Yeah. See you tomorrow morning.